Hi everyone, today we have permutation with replacement, repetition or return task 2. So we have a problem 2 which states in how many ways can we create 5-digit number out of the 5 numbers which are 1, 2, 3, 5 and 6. To solve this problem we can imagine that number 1 represents a ball which has the number 1 and number 2 represent a ball which has the number 2 and so on. In mathematics this is known as mapping. We are mapping this number into a tangible object. The reason we do that is we try to simplify it and turn the intangible number into tangible object, which makes it more easy to understand. So now we map number 2 into ball 2 and so on until we finish all the numbers. Now we put all these numbers on all these objects into the container and imagine that we are withdrawing from this container. But before we do that, we have to know is order of the event is important. So if we are withdrawing the first number and the second number, does it really matter if the first number comes first and the second number comes second? It does. Why? Because in number theory, the order of digits will change the number. So here we conclude that order of events or order of numbers is important. As we see here, 1, 2, 3, 5, 6 is different from this number 2, 1, 3, 5, 6, even though they have the same digit, but the order is different, so two numbers are different. So if order is important, then we have to define the events. First event, withdrawing the first number or the first ball, and second event, withdrawing the second number, and so on. Now we have to know if replacement or not replacement is there. So when we are withdrawing a number from this container, can we replace it? Nothing in the problem says we cannot replace it. And if we change from standpoint of number theory, if we withdraw number 1 twice or 5 times, would it make a different number? It would make a different number. So we have to follow the rule of replacement. So we can see here 4 is repeated twice, 1 is repeated twice, 5 is repeated 3 times, and 2 is repeated 5 times. And this repetition is creating a different number. And nothing in the problem indicates that we cannot do that. If the problem stipulates and states clearly that the number cannot be repeated, then the problem would imply that there is no replacement. But for this problem, replacement is necessary. So let's look at this number here. We have number 2 repeated once, twice. So number 2 is repeated twice in this number. And this whole issue, this whole problem is analogous to withdrawing a balls from a container. So we are withdrawing number 2, we are replacing it, returning it to the urn, and then mixing the balls and repeating that 5 times until we get this number, for example. Now the last condition we have to examine is the number of objects equal to the number of events? We have 5 objects, we have 5 numbers, and we are withdrawing them one by one. How many times? 5 times. So that means that the number of numbers or object or balls is 5, and the number of event withdrawal is also 5. So R is equal to N, and now the 3 conditions are met. Ordered events with replacement and N is equal to R, which means we can apply this law here. we can apply the formula permutation with replacement of n different objects taking n as a time. Or we can say permutation with replacement of 5 different numbers taken 5 at a time. Or we can say permutation with replacement of 5 different numbers taken 5 digits at a time, which is 5 to the power of 5, 3125 different numbers we can compose out of the set 1, 2, 3, 5, and 6. So we have applied the previous formula, PR and N, under the 3 conditions here. So the 3 conditions are met, therefore we can apply it. In general, we can use the following table to compute the number of possible events. We have 5 events, and we write these events in order from the first event to the 5th event, and the number of ways each event will occur, which is 5 ways for each. And now we can get the number of possible numbers, which is 5 to the power of 5. So these are all possible numbers that we can generate from the set of 5 numbers mentioned before. Or we can write in more abstract way. We can represent every event with a cell. We write cell 1, 2, 3, 4, 5 for the 5 events, and the number of ways of filling every cell is 5, and now we have the number of sequences of all possible numbers. Thank you very much for listening, and we are going to study more and more complicated issues with gradual difficulties. This is just a very simple beginning.